Hey everyone, welcome to the today's LeetCode problem of the day. So today's problem of the day is count subarrays where max element appears at least k times, and which is a medium level problem. And if you have seen the pattern from few days, LeetCode is asking all the questions related to the subarray. And if you haven't seen the previous video on the channel, I would recommend you to watch that video because the intuition is same for this problem as well. The previous problem is also related to the subarray only. So what we have been given, we have given the integer array nums and we have given the integer array k, and we have to return the number of subarray where maximum element of num appears at least k times. Okay, let's see the test case. We have given this test case here. If you see, max element of this array is a 3, and we have to find all subarray having 3 at least 2 times. So if you see, this is the one subarray because there are 2, 3. This can be the second subarray. This can be the third. This can be the fourth, correct? Because this is also the valid subarray. This can be the fifth, 2, 3, 3, correct? And sixth one is this whole subarray, this whole array basically. So if you see, there are total 6 subarray having at least 3. See, at least 3 means there can be more than 2. Sorry, at least 2 means there can be more than 2, 3 also allowed. So if you see in this subarray, there are 3 threes. We have been asked at least 2, so it's fine. But there should not be the case where subarray is having only 1 3. Count of 3 is 1. Why? Because we have been asked to maintain at least 2. This is the case. If you come here, k is 3 and max element is 4. If you see, there is no subarray because 4 frequency itself is a 1 only in whole array. So there is not a possible case where any subarray will have 3 times 4, correct? So we have to solve this problem. What is the constant? If you see, constant is given 10 raised to 5 array length. So it means we have to solve this problem in big of n or big of n log n solution. Big of n square is not possible. So how we can solve this? So what I will do, I will just take the same array over here, that is 1 3 2 3 3 3 1 3 2 3 3, and we have been asked k equal to 2. What is our first approach? First approach is what is the max element, correct? That will be our first case. Max element is nothing but 3. Okay, now what we have been asked? We have been asked at least k times, correct? So if I have been asked at least k times, just tell me one thing. If you are getting, for example, if this is my array, okay, these are my positions of the element. If I am satisfying the condition at least k times till here, can you just tell me, is this the valid subarray? Because my condition is being satisfied. Yeah, it is. So will this be also the valid subarray? I would say yeah. Will this also be the valid subarray? Yeah. Why? Because this part of the these 3 subarray is following the condition. And what is the given? We have been asked at least only, right? So at least means this part is following. So I know that this part will also follow, this part will also follow, because I don't care what elements are here in this part, because this part already is following the condition. Okay, makes sense. So it means that whenever I'm getting, for example, if my j pointer is here at this condition, so I know that the valid subarray at that j will be nothing but length minus j, and this we have already seen in the previous video as well. So if you see, if length in this case was 5, 1 2 3 4 5, so 5 minus j is 0 based indexing, so this is a 0 1 2, so j at the second index, so 5 minus 2, that is a 3. So I can form 3 valid subarrays which are satisfying the condition. And if you see, we created 1 2 and 3. Makes sense. So if you see, the intuition is kind of this sliding window only. Now I know that whenever I am satisfying this condition, okay, this condition, I will try to shrink my window because I have already counted all possible subarray using that window. So shrinking means what? If my j pointer is here, I will try to move it to the next index, to the next index, to the next index, and every time I will check whether still I am following the condition or not. What is the condition? That is frequency of max element is greater than equal to 2. If it is a case, again I will do the same thing, length minus j, and this is same thing we have done in a previous video as well. So if you see, pseudocode will be nothing but like this. What will happen? I will run my while loop while j till less than n. Suppose n is my length of array. Done. Then what I will do? I will just maintain the frequency hash map where I will just say num of j. I will just increment its frequency by 1. Correct? Now my condition is that while whenever I am getting frequency of max element, whatever the max element we have is greater than equal to k. Okay, it means that I have found the condition now. This is my condition. I have found the condition. What I will do? I will first maintain the answer count variable basically. So count will be, I will just update my count plus equal to length minus j, because this is the valid subarray I have found. Correct? Now I will shrink my window. Shrinking window means what? First update the frequency of ith element, that is num of I, because I am incrementing my I, so I have to make sure I am decrementing the frequency, and I will just say I plus 1, I plus basically, and this is what we will do. And at every step, after every step, I will just update my j to the next index, that is j plus 1, and finally I will return the count, because this count will contain the valid. So simple only. This is what the approach for this problem is. So what I am doing, whenever I am getting the valid window, this is the case. Wherever I am getting valid window, I am just putting the count, because valid subarrays will be nothing but length of array minus the current j index. Because if this is valid window, I know that this will also will the valid window, this will also will the valid window, because the subarray is following the condition. So this was it. And if you see, the time complexity will be the big of n only, because we are visiting the each element at max twice if I is considering. Correct? So let's see the code. Code is also simple. What I have done, I have taken the frequency hash map, right? I have taken the ij and n variable. I have find the max element using the max built-in function of the Python. I am using the count variable. I am running my loop while j is less than l, that is big of n. I will run this till big of n, right? Then I am updating the frequency of jth element. I am checking now if this can be greater than equal to or equal to. Both are fine. Okay, both will work. So whenever I am finding the max element is equal to k, means I have found max element frequency at least k times, means equal to k time. Then what I am doing, I am updating the count variable, that is n minus j. We already discussed length minus j. I am updating the frequency of I element, because I want to shrink my window, and I will shrink it and I will move to the next element. So if this is my subarray, if my I is here, my j is here, shrinking means what? Moving it to the next index, that is I plus 1, and I will update every step j plus 1, and finally I will return the count. So time complexity would be the big of n here, and space also big of n. Why big of n? Because we are using the frequency hash map over here. So I hope you got this problem. See you in the next video. Thank you.